I'm Dave Philpott, a heating and air conditioning instructor at Advanced Technology Institute at Virginia Beach, Virginia. On this ATI Quick Fix, we'll look at the transformer. The transformer. It's an important component in the HVAC system. Without it, you don't have control voltage for components like, well, this guy right here, the contactor. Now the way this works is 24 volts will come into this thermostat, and the thermostat is going to send a signal to the contactor, for example, whenever I switch it over to cooling. When contactors and relays don't work the way they're supposed to, a lot of technicians want to blame this little guy. What we're going to do is have Darren, one of the students here at Advanced Technology Institute, show you some techniques for troubleshooting the transformer using the multimeter. The meter will be set to resistance so that we can measure the continuity of the primary and the secondary windings. First, Darren's going to measure the primary of the transformer. We want it to read some resistance, and depending on the transformer, the resistance can vary. In this case, it's right around 84 ohms. Next, we're going to see Darren measure the secondary side of the transformer, and in many cases, this is going to read less than 1 ohm, so it may look like a short. Be sure to check the resistance, it will be very small. Working on a bench is great, but most of the time out in the field we're not going to have a bench available to us. So we're going to have Darren demonstrate these troubleshooting techniques on an actual furnace. Darren starts by killing power at the switch. If this were a 240 circuit, it would be the disconnect. The transformer is almost always located at the indoor unit. On a gas furnace, you'll typically find it in the blower compartment. Remove the power wires to isolate the primary. Using alligator clips with this meter will ensure a good connection on the transformer. This is a 120 volt transformer, so you'll note that the primary side is 20 ohms. Applying the alligator clips to the secondary side of the transformer, we can see that the resistance here is less than 1 ohm. The next step will be to check the voltage of the transformer. The gas furnace has a door switch on it, which means that we can energize our switch here and then use our door switch as the disconnect for power whenever we're troubleshooting it. First, we'll see Darren check for voltage coming into the transformer. He's going to check the wires that actually connect to the primary. Energizing the door switch, he can now check the voltage. He's reading 123 volts, which is right in the ballpark. By letting go of the door switch, the power is killed to the wires and Darren can plug it back up safely. Now he'll check for 24 volts present at the secondary side of the transformer. He applies power and has control voltage, a little higher than 24 volts. Here is an example of a faulty transformer. As Darren checks the primary side for continuity, he finds that it's reading open line, indicating that the winding is open. You don't ever want to condemn a component without first verifying it with a meter. That way you can save yourself and the homeowner some time and money. After taking off the wires, the faulty transformer is removed. A new transformer is put in place and held in by 2 screws. Be sure to connect the wires back properly whenever you're finished. You can either take a note of the wiring diagram or you can take a picture of it with your cell phone or whatever you have handy. You can also check the schematic for the proper wiring configuration. Anytime you're troubleshooting, you want to observe electrical safety. Ask your instructor if you need further training.